Hello, everybody. Welcome back. We are starting a new chapter today. So, we are going to be looking at radicals over the next 2 weeks. In your book, the chapter is called Roots, Radicals, and Trigonometry. We will not dive into those other two topics. We're mainly going to be looking at radicals. All right. So, today's lesson is going to be a two-parter. So, we will start basic today by just simplifying radicals and identifying what is a radical. And then I believe on Thursday, we'll add a little bit more to that. So this week is just going to be simplifying radicals. And then next week, we're going to be doing those operations with them. So what is a radical? Well, you've probably seen these expressions and they look very daunting and very daring. And you're like, what the heck is that caret thing sitting on top of that number or variable? I'll give you a hint. It's not as bad as it seems. Same with a lot of math. Like a lot of math looks very, very crazy and daunting because you just haven't experienced it yet. And I believe that's the same with radicals. And hopefully you'll see that as we dive more into this. So what is a radical? Well, first, let's talk about the components. You are given this little caret thing right here. Okay, that is known as our radical. And the way I like to describe radical is it's kind of like taking the square root of something. You've probably heard that in the past. Take the square root of a number. You've dived into that basic format. Well, it's kind of going the backwards form of squaring something. So for example, if I had the number 4 and I took the squared value of that, so 4 times 4, that would give me 16. Well, if I took the square root of it, meaning I have that radical over it, I would get 4. So it's basically doing that backwards format. Oh, not my eraser. Backwards format. Okay. Underneath our bracket, our radical is kind of, I like to call it the junk in the trunk. That's called our radicand. And then right here, that little n, that is known as our index. Most of the time, there is no index written. It's kind of understood that if there's no index, it's just an understood 2, meaning I'm taking the square root of it. You can take the cube root of it. You can take any number, any variable to the root of a radicand. However, most of the time we use 2. So we do not have to write that index. Okay. You have probably experienced perfect squares in the past. Meaning if I take the square root of something is equaling a whole number value. So it's a number created by squaring a whole number. So it's those nice and pretty and easy ones. If I take the square root of 9, I get 3. So here is this list. I'm going to tell you, this list is very, very important for simplifying radicals. It's the first 12 perfect squares. So if I take the square root of 1, I get 1. Square root of 4, I get 2. Square root of 9, I get 3. So you kind of catch on this trend. It's taking the square value of the first 12 numbers. So 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. So you don't have to memorize this. You just have to know the square values of the first 12 numbers in the number line. Why is this important? Well, if I take the square root of any of those values, I get a whole number. And that's going to help when we're simplifying non-perfect squares. So let's do some examples of some perfect squares. What is the square root of 16? That is going to equal 4, because 4 squared equals 16, or 4 times 4 equals 16. All right. Here I have a little junk in front of my trunk. So I have, for example, I have 2 square root 121. What do we do if we have a number in front of that? Well, you want to think of this expression as 2 times the square root of 121. So kind of like, think a little bit of PEMDAS. You kind of want to think of that square root as its own number or its own parenthesis set. So we're going to solve that radical, then multiply it by whatever is in front of our trunk. So what is the square root of 121? Well, that gives me 11. Now that I've gotten rid of my radical, I can multiply those together. So 2 times 11 gives me 22. Right? Let's look at example 3. I have 6 square root 289. What is the square root of 289? Well, that is 17. Now, I'm not expecting you to memorize all of these. That's why you have a calculator. Okay, so type in square root of 289, realize, okay, it's a whole number. So I'm going to write that whole number, which would be 17. So I have 6 times 17, which gives me a value of 102. All right, for example 4, I have 3 square root of 400. The square root of 400 is 20, so that leaves me with 3 times 20, which gives me 60. All right, not too shabby. So with perfect squares, you simply just solve that square root, get your whole number value, and if you have any junk in front of your trunk, you're going to multiply that out. However, it's not always so nice and pretty. So what happens if we have a non-perfect square root? Meaning, if I take the square root of that, I'm going to get a decimal number. I'm not going to get a whole number. Which I want to make a statement. That decimal number, it's still correct. However, when we simplify, we want it in whole number quantities. So with non-perfect square roots, most likely you will have a square root in your answer. Okay? Oh. Somehow my sister hooked up her laptop with my iPad. So now I get all of her messages. Yay! Okay, so how do you simplify non-perfect square roots? First step, you are going to find the largest perfect square that the radical design is divisible by. Then you're going to break down that radical using this number. So remember back to, oh my goodness, elementary math, when you would make those lists. Oh my gosh, no one wants to see your morning Bitmoji. Okay, where you make lists of multiples, we will be doing the same process here. So I'm going to look at my junk in my trunk. I have the square root of 32. I want to identify, okay, what are some multiples of 32 that are actually perfect squares? So that's why this list back here of these perfect squares is really important, because I'm going to take those and see if they are factors of 32. So I start with my list. 32 divided by 1 gives me 32. 2 divided by 32 gives me 16. 32 divided by 4, that gives me 8. And I think those are the only multiples for 32. Looking at that list, which of those values are perfect squares? 4 and 16. I want the largest perfect square value. So what's bigger, 4 or 16? 16. Okay, hang with me for a second. Let me change my color back. Okay, so I'm going to use this set right here, 2 and 16. And I'm going to break up this radical into 2 radicals. So I will have a radical of 2, and I will have a radical of 16. And I'm going to put a multiplication sign in the middle. It's kind of the same as if I just had 32 normally and I divided it up. Okay, well, 2 times 16 also equals 32. So it's the same thing, same answer. We break up our previous radicals so we can simplify certain portions. So does the square root of 2 simplify to a whole number? No, it doesn't. So I'm going to carry that down. Does the square root of 16 simplify down? Yes, the square root of 16 is 4. So I get rid of my radical because I take the square root of 16. So that leaves me with square root 2 times 4. To rewrite this in its most simplified form, I'm going to move this junk to the front. So I'm going to have 4 square root 2 as my final answer. So the process for non-perfect square roots, I look at my square root, I identify, okay, what perfect square is divisible by that number. I break it up, and then I simplify the parts. I believe this process is best used by getting more and more practice. So let's look at another example. So example 6. Simplify the non-perfect square root. I have the square root of 180. If I take the square root of 180, it just gives me a decimal number. So I need to see how I can break up that square root and simplify the parts. So time to make my list. What are some multiples of 180? Well, 180 divided by 1 gives me 180. 180 divided by 2 gives me 90. Divided by 3 gives me 60. 4 gives me 45. 5, 36. 6, 30. Okay. Did I memorize those values? No. Okay. Type it in your calculator. Figure those values out. Or honestly, a little trick I've done previously is I've just gone to Google and been like, hey, what are some multiples of 180? And it's given me a list. Now, looking at that list, which values are perfect squares? Well, 5 and 36 are. Square root of 36 is. Okay, so I'm going to use 36. So if I break up 180, I'm going to break that up into a square root of 36 times a square root of 5. Does the square root of 36 simplify? Yes. That's the square root of 6. Does the square root of 5 simplify? Yeah. Ooh. Oh, I'm sorry. I don't know what I'm thinking. Square root of 5 does not simplify. So that just drops down. And my final answer is 6 square root 5. All right. Let's do another problem. Example 7. I have a square root of 147. I need to simplify that, so I'm going to make my list. What are my multiples of 147? Well, I have 1 and 147, 3 and 49, and I'm going to stop here. Okay. How do I know which value to pick from my multiples? Well, you're going to pick the largest square root. So if you notice, we start small on this side and go up, and on this side we start big and go down. So that means the next value on here, that's going to be the largest square root value. So once I hit, as I'm looking at this side, once I find a perfect square, that's going to be my value. So I'm going to use 3 and 49. So I break up the square root of 147 into square root 3 and square root 49. Does square root 3 simplify? No, it does not. So that's going to drop down. Does the square root of 49 simplify? Yes, to 7. I cannot leave that like that, so I'm going to bring that 7 to the front to give me 7 square root 3. All right? Okay. Example 8. I have the square root of 175. All right? Time to start my list to figure out what are some multiples of 175 so I can break that up. That breaks up into 1 and 175. 5 and 35. and 7 and 25. Well, 25 is a square root, a perfect square root, so I'm going to use that set. 175 breaks up into square root 7, square root 25. Square root of 7 does not simplify, so I'm going to drop that down. Square root of 25, that does simplify. If I do take the square root of 25, that gives me 5. So my final answer is 5 square root 7. Okay. Example 9. What happens if I have some junk in the front? Well, it's the same as in those previous problems. If I had a perfect square, I just leave that in front and I don't mess with that until I've simplified my square root. So let's make our list for 54. We got to simplify our radical first in order to combine. So 54, my multiples are going to be 1 and 54, 2 and 27, 6 and 9. Whoop! 9 is a perfect square. So, break this up. I'm going to have 2 in my front multiplied by, if I break up my 54, or actually let's backtrack for a second. I'm just going to rewrite this to give you guys a visual. 2 square root 54 is the same as 2 times square root 54. So if I break up square root 54, that gives me 2 times the square root of 6 multiplied by the square root of 9. All right, let's look and see if I can simplify those radicals even further. So I'm going to drop down my 2. What is the square root of 6? That does not simplify. Because if I break up 6, that gives me 1 and 6, 3 and 2, and none of those are perfect squares. So that's just going to drop down. Does the square root of 9 simplify? Yeah, the square root of 9 is 3. So now I have 2 times square root 6 times 3. So what can I combine there? Well, I can combine 2 and 3. So that gives me, 2 times 3 gives me 6. So I have 6 times square root 6, or 6 square root 6 as my final answer. Okay, so when you're given junk in front of your trunk, you just kind of let it dangle until you simplify that radical, and then you combine. Okay, let's try another one. I have 8 square root 128. So let's make my list for 128. 1 and 128, 2 and 64. Ding, 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 ding. Square root of 64 simplifies. That's a perfect square. So I'm going to expand this. I have 8 times square root of 128. You do not have to write this step. I'm just showing you and demonstrating how that's multiplied. Square root of 128 breaks up into square root 2 times square root 64. I have 8 multiplied by, my square root 2, that does not simplify, so I leave it there. Square root of 64 does. It simplifies down to 8. So then when I combine 8 and 8, I get 64 square root 2 as my final answer. Okay. Last example, what happens if I have a negative sign in my problem? Well, leave it there. Leave it at the front. So it's the same as if I had a whole number. I'm just going to have negative 5 up in my front multiplied by 150. Okay. As you get in the method of making your list, you will get quicker. For example, if I have 1 and 150, that most likely is not going to be one of my perfect squares, because I would have just taken the perfect square from the beginning, so I do not have to include that in my list. Okay, I have 150. That's divisible by 5. It's divisible by 10, which 5 and 10, neither of those are perfect squares, but their corresponding partner may be. You just kind of get in a method of identifying, okay, that's not going to work, that's not going to work, that's not going to work. So as I go through my list for 150, I notice that 150 divided by 6 gives me 25. that's going to work. Okay? Because anytime you have a 0 at the end, it's going to be divisible by 10, 5, 25, and that should work. Okay? So I'm going to break up my 150 into square root 6 multiplied by square root 25. I'm just going to drop my negative 5. Square root 6 does not simplify, so I'm going to drop that square root 6. And then square root of 25 does simplify down to 5. Now I combine those whole numbers. So I'll take negative 5 multiplied by 5 to give me negative 25. And I just drop my square root 6. So the negative sign does not change the number. You just tack that on at the beginning. Okay? That's all I have for you today. So if you have any questions in this process, please let me know. You have a MyMathLab assignment up on Pearson, and you guys have a great day. Welcome back.